The human mind is traditionally viewed as a biological mystery. It appears subjective, fluid, and squishy, traits that seem incompatible with the rigid, deterministic tools of hard engineering. As a child, Dean Radin told adults he wanted to be jet-propelled. He spent his early career far from the laboratory, working as a professional classical violinist while experiencing synesthesia, a neurological condition where he perceived music as physical textures. But his focus eventually shifted toward the mechanics of the mind itself. He traded the concert hall for academia, earning degrees in electrical engineering and a PhD in educational psychology. He spent 10 years in advanced telecommunications research at AT&T Bell Laboratories, tasked with designing national network interfaces. He was dissecting how humans interacted with complex automated hardware on a granular level. This fusion of systems engineering and cognitive psychology caught the attention of the U.S. government. They recruited him as a visiting scientist for the Stargate program at SRI International, where he spent a year investigating the use of remote viewing for psychic espionage. Radin applied the rigor of a systems engineer to the study of consciousness. He treated the human mind as an antenna and human subjectivity as a signal processing problem to be isolated using hardware-level controls. If the human brain actually receives anomalous information, that faint signal is buried. It is drowned out by the noise of constant environmental stimuli and psychological bias. Measuring these effects requires the removal of human biological error. Radin realized that direct mind-matter interactions could only be validated by fully automating the laboratory protocols and hardware. In the hard sciences, an anomaly doesn't exist just because it happens once in a locked room. Proof requires exhausting repetition. To find the signal, researchers rely on meta-analysis. This mathematical framework aggregates the results of independent studies from multiple laboratories to detect systematic deviations over time. This search for consciousness takes place within massive datasets, where researchers hunt for minute, systematic deviations that distinguish a faint signal from background noise. To cut through external noise, parapsychologists developed the Gansfeld protocol. It is a sensory homogenization technique designed to block out the physical world. A subject, known as the receiver, sits in an acoustically shielded room. Halved ping-pong balls are taped over their eyes, bathed in a static red light, while headphones play continuous white or pink noise. Simultaneously, in a separate electromagnetically shielded room, a sender stares at a randomly selected target image and attempts to mentally transmit it to the isolated receiver. After 30 minutes, the receiver enters the judging phase. They are presented with 4 options: the actual target image and 3 randomly generated decoys. They must select the image that most closely matches the mental impressions they recorded during isolation. This chart shows the mean chance expectation, the 25% probability of guessing correctly. Over thousands of trials, random guessing will always settle on this exact baseline. But when Radin and other researchers compiled decades of automated Gansfeld data, the actual hit rate climbs persistently above chance. Data for external information transfer is robust, but Radin also examined internal temporal processing. He began studying the phenomenon of physiological anticipation. In mainstream physiology, this is known as predictive anticipatory activity. It is the unconscious arousal of the sympathetic nervous system occurring right before an unpredictable event happens. To measure this pre-feeling, researchers attach electrodermal sensors to the fingers of a subject's hand. These wires track skin conductance levels, which serve as a sensitive indicator of autonomic arousal. This is the experimental timeline. The subject presses a button to initiate a trial, entering a silent anticipatory window lasting 1 to 10 seconds. During this block of time, they look at a blank screen. At the precise end of that window, a hardware random number generator selects a stimulus. Only then does the computer choose and display the image, either a calm, neutral photograph or a highly emotional, violent one. Here is the anomaly. The skin conductance level spikes significantly inside the silent window, but only on the trials where an emotional photo is about to appear. The body physically braces for the impact of a violent image, seconds before the computer has even chosen to show one. This is a highly replicable effect. An independent meta-analysis of 26 separate reports validated this fixed effect size with a p-value of less than 2.7 times 10 to the negative 12. The human autonomic nervous system reacts to future stimuli before they are physically generated, challenging the linear arrow of time. Orthodox academia has pushed back against these findings. According to the current models of physics taught in these institutions, multi-sigma anomalies like presentiment are impossible. Skeptics, including psychologist Ray Hyman and mathematician I.J. Good, attack the data using a specific statistical argument known as the file drawer effect. The hypothesis claims for every successful published trial, there's an archive of thousands of failed experiments that researchers deliberately hid away to skew the results. Critics also dissect the laboratory protocols, searching for any terrestrial explanation, from acoustic sensory leakage through the headphones to minute flaws in the computer's randomization algorithms. The mainstream consensus relies on a strict principle. Because there is no known physical mechanism for a mind to interact with matter at a distance, any statistical deviation must be assumed to be an artifact of experimental error. In the absence of a theoretical mechanism, the burden of proof is immense. To a strict materialist, even flawless statistical data is viewed as system noise rather than a valid signal. Radin's counterargument addresses this skepticism directly. His meta-analyses counted the exact number of unpublished failures it would take to bring the Gansfeld and presentiment results back down to chance. The volume required is mathematically implausible. When evaluated by the exact same statistical thresholds used in medicine and physics, the parapsychological data proves equally consistent and unyielding. This creates a profound impasse. The statistical data exists, but the orthodox materialist framework lacks the physics required to accept it. Radin has presented this exact paradox to the highest echelons of the scientific establishment, from Google to Harvard Medical School. His ultimate hypothesis posits that these phenomena are not supernatural events. They are natural, non-local properties of consciousness, interacting directly with the physical world. By mapping anomalous phenomena onto the architecture of electrical engineering, Radin forced a shift in the conversation. The result is a transition from a debate over belief to a quantifiable crisis of data. We will track the measurable footprint of human intention across the quantum scale, the biological mesoscale, and a planetary macronetwork. Steadily, if consciousness acts as a physical force, it must consistently violate the null hypothesis at each of these scales. We begin at the quantum level with the double-slit experiment, the standard demonstration of the quantum measurement problem. In this setup, firing photons through two parallel slits generates a wave interference pattern. Adding a physical hardware detector to observe which slit the photon passes through collapses that wave function into a distinct particle state. Radin modified this test by substituting the physical hardware detector with human attention. The apparatus is sealed inside an electromagnetically shielded, double-walled steel room on a vibration isolation mat to prevent environmental contamination. Isolated participants are instructed to mentally focus their intention on the optical slits during specific 15 to 30-second intervals. This chart shows the baseline for wave interference. Without an observer, the light intensity produces a sharp, high spectral power peak. During the intention intervals, the interference pattern physically alters. The wave peak drops and flattens into a single-slit diffraction curve. Across 6 experiments and 250 test sessions, this drop yielded a z-score of negative 4.36 and a p-value of 6 times 10 to the negative 6th. The data revealed that participants with extensive meditation training produced a stronger collapse effect than those without a practice. At the microscale, human consciousness functions as an active variable capable of collapsing quantum states. Testing the next scale involves observing whether intention can imprint on complex biological matter. Radin applied randomized, double-blind, placebo-controlled protocols to evaluate the effects of focused blessings. In one study, Tibetan monks directed focused intention toward batches of dark chocolate. Volunteers then consumed either the treated chocolate or an untreated placebo over 3 days. This table compares the outcomes. The group consuming the treated chocolate reported specific mood improvements, with p-values of 0.01 for decreased fatigue and 0.002 for increased vigor compared to the placebo. A separate experiment involved 1,900 participants directing distant intention toward shielded water samples in California. Ice crystals formed from the treated water received higher aesthetic ratings in blind evaluations, yielding a statistical significance of p less than 0.03. Radin also observed physical changes in Arabidopsis seeds irrigated with intentionally treated water. These seeds grew shorter, thicker hypocotyls, a structural marker of sturdy early development. These outcomes suggest focused intention exerts a measurable influence on the development and subjective experience of biological matter. Scaling the effect to a planetary network represents the ultimate macroscopic test. The Global Consciousness Project utilizes 70 hardware random number generators distributed across the globe. These devices produce synchronized sequences of 200-bit trials established on a mathematical baseline of pure quantum randomness. The project tests if moments of synchronized global emotion skew this quantum noise into measurable order. This map illustrates the baseline network activity. Prior to major events, the data shows uncoordinated statistical variance. During the events of September 11, 2001, the fluctuating lines snapped together. The network moved into a synchronized upward trend as billions of people focused on the tragedy. Researchers evaluated 500 pre-registered global events over a 20-year period against this random background. Ultimately, the cumulative statistical deviation reached a 7 sigma anomaly, with odds against chance exceeding 1 trillion to 1. Collective consciousness appears to act as a field capable of forcing order onto planetary-scale physical randomness. This data poses an epistemological paradox regarding how consciousness manipulates matter across multiple scales. Radin proposes resolving this by replacing reductive materialism with dual-aspect monism. The mathematical topology of the Klein bottle provides a visual aid for this concept. The geometry shows that the interior, representing mind, and the exterior, representing matter, are a single, continuous surface. Dual-aspect monism defines mind and matter as context-dependent perspectives of a single psychophysically neutral reality. This empirical framework parallels the mechanics of consciousness recorded 2,000 years ago in Patanjali's Yoga Sutras. Radin's research positions these siddhis, or supernormal abilities, as the latent engineering potentials of highly trained attention. The 40-year statistical record provides an empirical basis for treating consciousness as an integrated variable in the physical environment.